Hi, this is Russ Anderson. Welcome to part 4 of the tutorial. This part is actually a follow-on to part number 2. Now in part number 2, we did a 3D solve of a linearized window into our shot. So this is what you might see if you were looking at it through a heads-up display. So you're not seeing a full 360 VR image here, but just a window into it. And the resulting 3D solve is shown up at the top with our camera path and some tracker locations. But because that was determined just from that relatively smaller view, there aren't trackers in the rest of the environment. And that's what we want to address here, creating additional trackers throughout the 3D environment. So we're going to do that just by starting off, and instead of going immediately to a stabilized version of the shot, we're going to go back to a 360 VR version that's exactly what the camera sees as it follows along that path. And that has, what it's looking at is right down in the middle of the shot. So as a consequence, you see this very irregular horizon line that's reflecting the 20-degree down tilt of the camera view that we initially created. But the one thing that you should also notice from this is that the camera mount, the vehicle, is actually stabilized in this view. So it's not really doing very much. There's a little bounce in the mount and so on, but it's basically standing still there. And that makes it much easier to mask out the vehicle itself that's carrying the camera. So that's what we're going to do next. We'll flip over here to the Roto panel and start creating a little Roto mask. So I'm going to just go clicking around the boundary. I just double click there to switch to a straight linear boundary. I just right click to end that process. So let's just adjust this a little bit. Oops. I'll double click those. So there's our initial garbage mat for that vehicle. It might go a little out in the middle there, so I'm just going to go to the beginning and move that one corner a little bit. So I could go throughout this shot and animate the vehicle motion, animate this mat a whole lot if I needed to. But if you have to do a whole lot of animation of this mat, that's really telling you that this isn't the right method to use. You should probably just use the other method. This method is just intended for situations where the vehicle is rigidly mounted to the camera, vice versa, so that you can just set up this mat at the beginning of the shot and have it be useful throughout it. So now I can just go and do the same thing on the other side. Just mask out this little wingtip also. So there we go. Now we've got those little masks set up to indicate that we don't want to be looking there as we create additional trackers. So now I'm ready to go over and basically do another little auto track. And I still got the same parameters from before, where we're using a minimum track length of 30 frames. And let's go, and we're going to have it look for features throughout the entire shot. You'll see there are all kinds of features there. And even if I have it just display the ones that are 30 or longer, you'll see that there's still an awful lot left, so that's good. So now I can just do the peel all that creates trackers from those possible trails. And there are a whole bunch more trackers now throughout the scene. So let me go over to the tracker view here just to reduce the clutter. And actually, let's just turn that guy off. So now you can see the trackers moving throughout the scene. But the one thing that you don't see are the little yellow X's that indicate that we know where the 3D locations are for those. In fact, if we go and look at the 3D views, you'll see there's nothing out there. That's because we created regular trackers. And normally we do the 3D solve again and just augment the 3D solve. But with a 360 VR shot in this mode, the solver doesn't work with it. So we need to do something else. And that other something is to use zero-weighted trackers, which are able to work in this situation and basically take advantage of the fact that we've already got the whole camera path. So you can compute the position of the trackers just from that camera path. So to make this setup easy, I'm just going to use Cynthia here to do this and tell it I want to make all the unsolved trackers zero-weighted trackers. So, okay. Bingo. And for those of you who wonder, what's the Cynthia thing for? That's it. You could go and try and figure out how to write a script to do that and spend a bunch of time doing that, or you can just type in one line that says pretty directly what you want to do and have it get done. So that's what Cynthia is great for. And you can, in fact, put a little command like that onto a button and put it on a toolbar if you want. So as a result of that zero-weighted tracker process, now we do have trackers with 3D locations throughout the scene. You can see one of them is a little on the crazy side up there. And so we'll just delete it. But let's go and take a look at all of them in general and just make sure that they're all fairly reasonable. So I'm going to go and sort the trackers by error. So now we can see that worst one is around almost 9 pixels of error. And then it starts dropping off. So maybe we'll just take out the top 2 or something and hit delete. So that's just a little quick tracker cleanup for these zero-weighted trackers as well. Now, having done all of this, now we're in a position to go back and stabilize the shot to make it more usable and viewable. So we'll just go and run that script now and have that get recomputed. Doesn't affect the 3D view except for the camera. Now you see that the camera orientation is now facing due north. It's exactly level and so on. So that our horizon line is now set up exactly right. So there's our cleaned up version here. We've got trackers throughout the scene. And we've got the stabilized shot. You see the sun is sitting nicely in the same direction. And now you see the ultralight is moving around in the image. And if we had tried to do the roto on that moving position of it, we could have done it, but it just would have taken longer and been more of a bother. So we use this method because with the camera fixed to the vehicle there, it makes that roto process easy. So that makes this method usable. If that isn't the case, then you can use the other method and just lasso some spots if you want as well. But the advantage of this method is that it does immediately give you a better distribution throughout the entire scene than trying to figure out where you want to lasso or not lasso. So at this point, we've now gotten to the same sort of view from part 4 here as we did from part 3. And now we're ready to move on to part 5, where we're going to take a look at this pointing direction of the camera and what some of the artistic choices are that we can make with that. So thanks for watching so far, and see you in a minute.